All right, welcome back. This is Exam Slam Video 2, and let's pick up where we left off. So we have these sides. We have to list them least to greatest, and now we actually have all three angles. So like we did before, but now going greatest, the greatest angle is 128, so A would have to be the biggest side. And then 27 is the next biggest, and so side B would be the next longest side, and then 25 would be the shortest, okay? So I listed those, A, B, and C, I've listed them least to greatest. Now kind of ignoring the big triangle and just focusing our eyes on this smaller one. Now I want to list this one greatest to least. The problem though is once again, I don't have that angle. So just like the last problem, or just like the last triangle, I'm going to add those angles together, get 67, and then subtract that from 180, which will tell me that missing angle. So 180, excuse me, got to clear that out, 180, subtract 67, and we get 113, okay? So now, here was the work I had showing adding 25 and 27 to get 52, subtracting it from 180 to get 128. Okay, so now we know all three angles here, ordering them greatest to least. Side C is the greatest, so we can kind of think about just covering it up. If I had to order this one greatest to least, this is the greatest, then 35, so it would be D. Then last, 32, so that'd be E. So it looks like choice A. Don't just circle choice A though. Make sure you've got these notes. Now let's keep going. This question here is a good one. It says, please show that a triangle, so you should see triangle ABC, here it is, in which AC, so that's this line right here, is parallel to line BD. So when they tell us two lines are parallel, we know we can add two little carets. And we also know that the angle relationships exist. AIAT, AEAT, CAP, SSIAT, SSEAT. These five angle relationships are present or could be present when I have two parallel lines. So now kind of looking at what my transversal is. So if I look at that transversal, it looks like this. Angle 5 and 3 make a Z that spells AIAT. These two angles are alternate interior angles. And so what that means is angle 3 has to be equal in measurement to angle 5. Now, I also kind of see a Z over here. So if I see one Z, it doesn't necessarily mean that there's not more Z's. I'm noticing this Z. So if these two lines are parallel, this would also be a transversal. And angle 4 would be equal to angle 1. But I already put one necklace here, so I'm going to put a second angle, a different angle, are also equal. Angle 4 is equal to angle 1. Now, let's see what they're setting out to make us prove. They said in the space below, prove that the sum, or when I add up all the interior angles, so specifically the angles that are inside, would those equal, or should those add up to 180? Well, we already know that the angles inside a triangle add up to 180, but they'd like us to use additional information. Prove it to me. Okay, that's exactly what we'll do. So, another interesting angle relationship I'm noticing is notice that all three of these angles would add together to make up that straight line. So I think that that's something that they might have wanted me to notice on top of everything else. So when that happens, if all of these angles make up a straight line, then all of these angles, angle 4 and angle 2 and angle 5, should add up to 180 because they make a straight line. Now, we already said that angle 4 is equal to angle 1. So I'm just going to substitute in the measurement of angle 1 for angle 4 because we know they're equal. That's substitution. Okay? I also know that angle 3 and 5 are equal. So I can just substitute the number 3 in there where I see the 5. And then I'm just going to copy everything else down. And looky what I did. We've proven that these are equal using simply angle addition and substitution. Okay, let's keep going. Let me just make sure you can see that. Now, next problem, it says, what is the volume of the outer ring? Interesting. So there's a couple ways to do this. We know, and there's no right way, but there's a couple ways. We know that the volume of anything in the universe is the area of the base times the height. So it looks like our height here is 2.2. And they don't want my whole coin. They actually want just this outer ring. So I could think of it as, well, if I knew the area of the ring, then I could just multiply that by the height. So the area of the ring would be the whole area of the top. And then if I just deleted this inner part, that would be the area of the ring. So it's similar to our subtraction area or the air around it. It's kind of weird. It's kind of just similar to this concept of the air around it. So if I found the area of the ring, it says the inner radius, the radius of the whole coin, or excuse me, the area of the whole coin would be pi r squared, and the radius of the whole coin is 11.5. So we would take pi times 11.5 times 11.5. Okay, so the area of the whole face of the coin is 132.25. Now looking at the inner part of the face of the coin, that would be pi radius squared. It has a radius of 8.5. So 8.5 times 8.5. $72.25 pi. I think I forgot the pi over here. Let me double check that. 11.5 times 11.5 is 132. Oh, and I still have this pi here. So I could turn these into regular numbers and subtract because it does say round to the nearest tenth. So that's what I'm going to do. So 132 times pi would be 415.476. Okay, so that'd be the area of the face. This one, 72.25 times pi, 226,980. 226,980. And again, I'm going to subtract to figure out, well, what would be the area of the outside ring? All right, and so I get 188.496. And now that I know the area of the base, I can multiply by the height times 2.2. And I get 414.69. And it said round to the nearest tenth, so 414.7. Cool.